Today's goal is to talk about different rates of change. That is, different ways of talking about how y values change as time goes on. Number one, the graph flow represents the number of yeast cells in a loaf of bread as a function of means the next thing is x, the hours that spend left to rise. Find the doubling time. Doubling time is exactly what it sounds like. It's the amount of time it takes for y values to double. Okay, what does this tell us about the yeast? So let's take a look at our graph. Initially, I can see that there were 10, 20, 30, 40, 50. Okay, good, my scale is 10. Initially, there were 20 yeast cells. So doubling time, the amount of time it takes to double. That is, I want to know when are there going to be 40 yeast cells. Well, it looks like right here. Let's see, this is in hours, so about a third of an hour. So the doubling time is about, I'm just estimating here, a third of an hour, meaning the number of yeast cells doubles every third of an hour. Okay, pretty straightforward. This might be helpful if you really want to make sure you know when your bread is growing. Let's take a look at another one. Suppose the population of rabbits in Central Park, X years after 1995, is given by this function. Find the annual means in 1 year, growth rate of a population as a percent. Well, let's take a look at this function. I can tell just by looking at it that 240 is an initial value, or that means 0 years after 1995, or in the year 1995, there were 240 rabbits. I want to know an annual growth rate. So what happened in 1 year? In 1996. 1996 would have been 1 year later. There were, I don't know, I'm going to have to calculate. 240 times 1.62 to the 1/3. This many rabbits. Well, I don't know what that is. 240 times 1.62 to the 1/3. Make sure that full 1/3 is an exponent. If your calculator doesn't put 1/3 up in small text, make sure the 1/3 is in parentheses. Okay, so we get 282 rabbits. We'll have to round. Can't have half a rabbit. Well, that means you grew some amount. I don't know what you can multiply 240 by to get 282. So again, going backwards means we'll have to divide 282, that number, divided by 240, or you could round just 282 divided by 140. It looks like to go backwards, you divide by 1.17, or to go forwards, you multiply by 1.17. So let's see. Let me just double check. 240 times 1.17. Oh yeah, that gives me approximately 280 rabbits. Well, 1.17 as a percent is 117%. Well, 100% means you haven't lost any rabbits, like it's staying the same, plus an additional 17%. There are more rabbits in 96 than in 95. So we would say the annual growth rate is 17%. That is, the population of rabbits is 17% bigger every year than it was the last year. Okay, in B, they're not talking about an annual growth rate or percent, they're talking about average rate of change. Average rate of change is just change in y over change in x, or slope. From years 1 to 5. Okay, so we need a change in y. To find a change between values, you subtract them. Just like if today I'm 300 pounds, tomorrow I'm 305 pounds, my weight has changed by 5 pounds. 305 minus 300 is 5. Okay, so I need 2 y values and 2 x values. From years 1 to 5, they're giving me the 2 x values. Here would be x1, here would be x2. I don't know how, I just did this calculation. 1 year later, if I sub in 1, I get 282 rabbits. So I'm just going to keep track of this over here. I need to figure out how many rabbits there are if I substitute 5 into this function. So f of 5, I'm doing some calculations off to the side, would be 240 times 1.62 to the 5 over 3. Grab my calculator. Again, 5/3 needs to be in parentheses or all up top. I get 536 rabbits. So that gives me the point 536. This is my x1, x2, y1, y2. Now I just need to substitute. And subtract. Grab my calculator. 254 over 4. I can divide right on my calculator. So this would be 63.5. That is the rabbit population increases about. It's an exponential pattern, which means they're not increasing by the same amount every year, right? It would be a slower increase here and a really steep increase. So if we're talking about an average rate of change, we'll say the increase is about 63.5 rabbits per year from 1996, that's 1 year after 95, to 5 years after 95 would be the year 2000. Okay, C, the doubling time of the rabbit population. Well, doubling time, again, the amount of time it takes for the rabbits to double. You started with 240 in the year 1995, double 240 would be 480. So we need to find out when is 480 equal to this function. We can solve by isolating the base, that is the number that's holding up the exponent. Okay, now I'm going to have to turn this into a log equation, or some of you like to take the log of both sides. It would make sense to have a base of 1.63. Oof, messily written. Let's try again. Log base 1.62, of 2 is equal to, this all cancels out, x over 3. I can isolate x by multiplying both sides by 3. So I have x is 3 log base 1.62 of 2. I can type that into my calculator to find an approximation. So I